Jupiter doesn't really have a solid surface like Earth. Instead, it's like a super thick gas that's squished together. The part we see is the top layer of this gas, where it's about as pressurized as the air on Earth. This layer is made of tiny ammonia crystals and is super cold, like minus 145 degrees Celsius minus 234 degrees Fahrenheit. As you go deeper, it gets hotter and denser, like being underwater but with gas. There are clouds made of ammonia, water, and other stuff, and the winds are crazy fast, up to 644 kilometers per hour, 400 miles per hour. It's like a massive, perpetual storm. Way down, around 25,000 miles below the clouds, the gas gets so squished that hydrogen turns into a liquid metal. This is what makes Jupiter's super strong magnetic field. And at the very center, there's probably a fuzzy mix of rock and metal, and it's ridiculously hot, even hotter than the sun's surface. Jupiter's atmosphere is like a big striped shirt, with lighter and darker bands. The lighter parts are where gas is rising, and the darker parts are where it's sinking. There's this huge storm called the Great Red Spot that's been going on for centuries. And Jupiter's magnetic field is the strongest in the solar system, trapping particles and making intense radiation belts. Jupiter's basically a big ball of hydrogen and helium, with some heavier stuff mixed in. It's huge, so it has a crazy strong gravity that holds everything together. Scientists are still studying it, like with NASA's Juno spacecraft, to figure out more about its atmosphere, magnetic field, and what's going on inside. The planet's moons, like Io and Europa, interact with Jupiter's magnetic field and atmosphere, making things even more interesting. And Jupiter's gravity affects the whole solar system, like a big player. Jupiter's ring system is a fascinating and complex structure that's often overshadowed by the planet's massive size and stormy atmosphere. Let's dive into the details. Jupiter's ring system is made up of three main components: the halo ring, the main ring, and the Gamow ring, also known as the Gamow lobe. The rings are composed of tiny dust particles and larger rock debris, ranging in size from a few micrometers to several meters. The halo ring is the innermost and thickest part of the ring system, extending from about 92,000 kilometers to 122,500 kilometers from Jupiter's center. It's a torus-shaped ring, meaning it's like a donut with a hole in the center. The halo ring is thought to be made up of tiny dust particles that are ejected from Jupiter's moons, particularly Métis and Adristia, due to meteoroid impacts. The main ring is the brightest and most prominent part of the ring system, extending from about 122,500 kilometers to 129,000 kilometers from Jupiter's center. It's a narrow, flat ring that's about 6,000 kilometers wide and 30 kilometers thick. The main ring is composed of larger particles than the halo ring, ranging in size from a few centimeters to several meters. The Gamow ring, or Gamow lobe, is the outermost part of the ring system, extending from about 129,000 kilometers to 226,000 kilometers from Jupiter's center. It's a faint, diffuse ring that's thought to be made up of tiny dust particles that are ejected from Jupiter's moons, particularly Amalthea and Thebe. Jupiter's ring system is relatively faint compared to Saturn's, and it's not visible from Earth with the naked eye. However, spacecraft like Voyager 1 and Galileo have provided stunning images and valuable data about the ring system. The particles in Jupiter's rings are thought to be constantly replenished by meteoroid impacts on the planet's moons. The moons Métis and Adrastea are particularly important sources of ring material, as they're embedded within the main ring and are constantly being bombarded by meteoroids. Jupiter's clouds are a complex and fascinating system. The planet's atmosphere is made up of mostly hydrogen and helium, with clouds of ammonia, ammonium hydrosulfide, and water. These clouds are dynamic, with winds reaching speeds of up to 644 kilometers per hour, 400 miles per hour, creating massive storm systems that can rage for centuries. The clouds are layered, with different types forming at different altitudes. The top layer is made of ammonia ice crystals, with temperatures around minus 145 degrees Celsius minus 234 degrees Fahrenheit. Below this, there are clouds of ammonium hydrosulfide, and deeper down, water clouds. The clouds are thick, with some layers extending up to 1,000 kilometers, 620 miles, deep. Jupiter's clouds are also home to some amazing features, like the Great Red Spot, a giant storm that's been raging for at least 150 years. This storm is so big that it could swallow several Earths whole. The clouds are also banded, with alternating east-west wind patterns creating stripes around the planet. The clouds play a crucial role in Jupiter's atmosphere, influencing the planet's temperature and weather patterns. They're also a key part of the planet's mysterious interior, with scientists studying them to understand more about Jupiter's composition and evolution.